Hi everyone, my name is Angelo Basile. Today I will talk about NLP in production, a couple things to think about. Couple words about me. I work as a research scientist at Simanto Research. It's a German startup. I mostly work on text classification task, and I work in close collaboration with the engineering team, so kind of involved in this production side of NLP. We recently started opening our API at Simanto for developers to use. We built all sorts of language technology tools, and in this work of productizing our technology, a couple issues have emerged that are peculiar to the production environment. So things that happen after you've done your research, after you've trained your model. And I thought it was interesting to share my experiences and what kind of problems I encountered and what kind of solution are out there with you guys. By the way, if you are interested in these sorts of tasks, just ping me this. You can request an API key and can do some stuff with it. The outline of the talk for today, I'll talk about three main topics, not really related, a bit related, not so much. So first one, large models perform well, but how to use them at scale. How to monitor their performance on new streaming data. So you have your large model, you have some numbers on your test set where you have the labels, but then the client is using your model and you would like to know if it's still performing well or not. How would you do that? And third, when you start to have a lot of these models, the infrastructure that's required for running them starts to grow very fast. And so it's nice if we can use some tricks for simplifying this infrastructure to make our life easier in production. Background. So what I'll present today is kind of the research view on what happens after the research is done. There's this nice paper from Sculley and colleagues, Google guys. It's called Hidden Technical Debt in Machine Learning System. Let me admit the label. Okay. And here's the abstract of the paper. Let me read it for you. As the machine learning community continues to accumulate years of experience with live systems, a widespread and uncomfortable trend has emerged. Developing and deploying ML system is relatively fast and cheap, but maintaining them over time is difficult and expensive. So we all think we can kind of train our machine learning model, kind of a stateless object. We deploy it, it will be there and serve the prediction, and will keep making money for us if we are working in a company. But this paper brings some argument that show that it's not so, it's not all that nice and easy, and things break, and you have to maintain them. And today I'll talk about some of the things that you have to do to bring your models to production, and what to do for not getting crazy when you're maintaining them, and how to control them over time. This is a nice picture, nice diagram from the same paper showing some of the usual components that are needed in a common ML infrastructure. And the first thing I want to point out is how small this ML code actually is. This part is. This is where all your ACL and EMNLP papers are. So maybe somebody collected already the data for you. Maybe you're working on improving parsing and you're already working on some trained tree banks. Collected tree banks, and maybe somebody else, the IT guys, are taking care of the machine, and maybe the quality team is working in the analysis side. This infrastructure is there because your ML code needs it in order to run it. So today we'll take a look at what kind of issues arise in several parts of this infrastructure. Large models first. Nowadays, we all like to use them. Things like BERT and GPT-2, they work well. Let's see, how many of you use this kind of models? Anybody uses them?
Well, we use it at Simanto, but I don't think I can say.
You don't count? Johan also? Nobody else? No. Okay, so they work well, but they're GPU intensive. And if you're lucky, you might have the GPUs you need for training these models or fine-tuning them. But what about the production environment? Does the engineering team have them for running your models? And even if you do, even if you're Google and have infinite resources, if you do have infinite resources, you probably also have infinite data, right, that you have to process. Say you want to parse the whole web, so you still might want to use some cheap machines, right? Or maybe you don't have machines at all. You're just renting virtual machines on AWS, and you know how expensive it is to rent machines with GPU. So it would be nice if you could just use CPUs instead, right? Second thing, these transformers are quite slow. If you use any sort of self-attention, you know that it's running time, it's quadratic. Since you are comparing each word with each other word, it's not ideal. So you might want to have something faster than that. And they're just, simply speaking, large. The pre-trained model itself is something normal for it to be something like 400 megabytes or larger. And if you are doing things like horizontal scaling, you have some sort of Kubernetes or Docker Swarm infrastructure, you want to spin up machines fastly, then it's not just nice to run these large models, right, to move them up and down from your repository. So these people, basically, what to do about them. First, answer to the problem is to use something else. And of course, this is not really an answer, but you should consider it. There is research on other architecture that shows that you can get good results. I don't know if anybody of you read this paper. I can highly recommend it. The people at Spacey also did some nice work with CNN recently. The performances are not really quite there compared to transformers, but the model is much more compact and fast. Some other options, you can quantize your model, so you have your large model, and then use some different kind of operation that don't require so much memory. So this paper by Intel claims that you can compress BERT by 4 times with minimal accuracy loss. And they say the quantized model, let's admit Julia, can accelerate inference speed if it is optimized for 8-bit integer supporting hardware, which I guess Intel is working on. TensorFlow has nice support for quantizing your models. The API is nice, and they provide support for quantizing the different kind of networks, but not all of them. So if you're not familiar with quantization, this is how it works in one image. So you have your network using float32, and you just say, find a nice way to convert them to use integers. And this work is fine. It's okay, but you're a bit constrained, since if you want to say quantize a certain network which is using this operation, the support for quantizing that operation must be there in the tool, and you might not have it, and so you might hit some limitation. Second method, layer dropout. In the same way as we do unit dropout, you can drop an entire layer during training. And there is this nice work from Facebook showing that what you can do is train your transformer, and then during training you have some probability P of turning off an entire layer, and then your network is robust against the absence of certain layer. And then at test time you can say, okay, just turn off 6th layer and give me a 6-layer transformer. So this is very nice. But of course you have to train transformers this way and then release them with layer dropout. So, and this Facebook actually did this for their Roberta model. Distillation is another option, and this is one I like very much for the reason I'm going to explain. this is a nice reference paper about the topic. And the guys in NLP Town published some result about distilling BERT, and with their permission I took this image. So this is how it works. Anybody here is familiar already with this?
Angelo, if you remind shortly what is distillation for everybody. So
yeah. So I was asking if anybody already, someone already is familiar with it.
I'm a bit familiar, so but
yes,
it would be nice to remind for everyone.
Yeah, of course. So the idea is to take your large model and distill it via imitation learning to a smaller model. So you take a small model and force it to behave exactly like the teacher model. So this is how it works. You have your training and validation data, and you train BERT on it using fine-tuning, and then you augment the data somehow by either corrupting the data or using some transformation. It's not so important, but the reason why it is important is you want the student model to observe the teacher in different situation, when it fails and when it succeeds. So you could have some text that is labeled, say you're doing sentiment classification, and have one instance with label positive, say, and then you have a corrupted instance with the label negative, maybe, and you want the student to observe how the model behaves in these situations. And then what you do, you train the student on the output of the teacher on this augmented data. And what kind of output you use? Some people use logits. We used Semanto probabilities, and it works very well. And it's nice because you don't need to change the output of your model. Say maybe you have already your teacher model deployed, you can just get the probabilities from it and use them to train your student model. Here are some results that we got. I had to anonymize the task here. And let me show you. These are F1 scores, so the higher the better. What you see here is a CNN, the result from a CNN character-based model, results from BERT model, and hard label. By hard label, I mean the actual label that was that we wanted to predict for the task. So if we're doing, say, sentiment, this would be positive or negative. And this student, the student architecture is exactly this same architecture that we have here. But this was trained on the output of BERT. So this has seen, if we were doing, say, binary classification, probabilities like to a vector of with 2 items. So probability for positive and probability for negative, say. And first, you can see that the improvement in performance that we gain with BERT compared to CNN is quite interesting. We get several points in some tasks. And with the student here, you can see that we managed to match or lose just up to how much? 1 point here, yeah. So that's quite a nice improvement in performance. So we managed to get the performance that we get with BERT with a smaller model. So, okay, with performance we're there. What about the other dimensions that we're interested in? So inference time and size, let's see. Number of parameters. You can see that we go down by quite a bit, and the size of the model also gets reduced considerably. These, of course, are the same because it's exactly the same architecture. So size also check, very nice. Inference time, this is interesting. This is where we would have been if we not have a method for using our BERT model at scale. So 9 seconds for 1,000 instances on a GPU. On a CPU, it's practically unusable. But interestingly, you can see that we get some nice numbers even on a CPU. So this is exactly everything we wanted. BERT level performance, small model, fast, that can run also on CPU. So can highly recommend using this method if it works for your task, for using large models in production. So to recap, some tips for a good distillation. should pick a student who is not too big. There is some work distilling BERT with just smaller BERTs, but then you still have all the inconveniences of the main model, just a bit better than that. Or if you're using, say, things like LSTM, you're still quite heavy on the GPU side. But it should also should not be too small, right? You still want the model to be able to solve the task by itself, so it should be expressive enough to solve the problem by itself. And we've seen that this CNN was already quite good for our task. Just probabilities, you don't need logic, it seems, so at least it worked for us. You don't need to change your model. And augment the data as much as possible. This is super important. You don't need high quality data, right? You don't need to make sure that the prediction from your teacher model are correct. You just want to the student model to mimic the behavior of the teacher as much as possible. So just let it run on whatever unlabeled data you have and use that. So the pros of using distillation for using your large model are that you don't need to change the model. Say, for instance, with this layer drop operation, there are no constraints on what operation you can use. This is something you don't have if you go for quantization, and it works in principle with every pre-trained model. So you have some complicated model that you're using, you can just distill it. The con is, of course, that you need to train a new model. Infrastructure. This paper that I was mentioning at the beginning, Hidden Technical Depth in Machine Learning, has a whole section on, wait, I think there's a good way to take a quick break. Do you have any questions so far on large models?
Yeah, just a quick question from me,
Yes.
if you don't mind. You said that you use distillation for the tasks you mentioned in your setup, but was distillation used additionally to quantization as well, or just pure distillation?
In our case, we just used distillation, but if you can in principle, right?
Right.
You could distill your transformer to something that you can quantize that doesn't have any constraints, and then combine both. Yeah.
Okay, cool.
There is work doing that. Yeah.
Sounds good. Yeah. Thank you.
Cool. Any other question?
Yeah. So, hey, yes. Can you tell a bit more about the CNN architecture you used?
Yeah, if you're familiar with this work from Zhang and colleagues, this deep convolutional neural network for text classification, I think it's a paper from 2015. Jan LeCun was among the authors. Basically, we have several kernels, and just then take some. We have a pooling layer in the middle, and then just concatenate them, and a couple of dense layer on top of that. Nothing really fancy. It was quite a common architecture for text classification for a while. I can share details. I can send you the link of the paper after the presentation if you want.
Okay, yeah, thanks.
Yeah. Cool. Infrastructure. So I was saying there's this section about what are called preprocessing pipeline jungles in this paper from Google. So if you have, say, 3-4 tasks that you are you have your API in production, and you are offering models for 3-4 tasks in maybe a couple languages, you start to get an interesting matrix there, and the preprocessing that you need for each of the models that you have there might change. So say, I need this specific tokenizer for this model, this other preprocessing for this other model. Here I need to lowercase, here I don't. You get crazy very soon, and that's the reason why we've seen some work like the TFX recently. This is some Google solution facing enterprises mostly for solving exactly this kind of problem. Keras recently introduced a text vectorization layer. It's still in the experimental namespace that allows you to embed the vectorization of the text inside the model so that you serialize it together with the model. There is a nice project called BERT as a service. What it does, it creates HTTP REST API that allows you to send your text to it via HTTP and get back the embeddings. And this is a very nice solution. It's a bit slow, but it works fine. And you could adopt something like this at a larger scale and do all the preprocessing that you need this way. So say if I need text for this model, I will send it to this endpoint and so on and so forth. But then you're just moving the complexity inside this API, right? Something I very much is this idea that's being adopted in this text vectorization layer, but it's not quite there yet. So I like the idea, but not so much the implementation. But you can just use low-level tensor operation. Say I just want to split at the white space or at every character, and then I can get a kind of stateless tokenization by using things like hashing. And you can build some quite complicated stuff with some frameworks like TensorFlow, because you have also support for regex and so on. But what I like of this idea is that you can use it for distilling your preprocessing pipeline. So in the same way as you distill your large models, because say if you might say I'm using this large complicated model that is using this costly vectorization strategy, so I cannot solve this using what I have available in the between the string operation in TensorFlow. But you could take the chance and say I'm going to use distillation just for simplifying the vectorization of my model. So I think it can be a solution for this kind of problems. Third topic we're going to talk. Any question about infrastructure and vectorization?
Yeah, actually, I have a question.
Yeah.
What do you mean that you can use distillation on the pre-processing step?
I mean that you can distill your model to something that needs nothing complicated for your preprocessing. So I'm going to distill only to a character-based model, say. And if that works for you, then it's a great opportunity for simplifying your infrastructure.
Okay, thanks.
Yeah. Any other question? No. Quality control. You got Sawtown parsing Wall Street Journal, but the client wants us to parse tweets. This happens. So you have your model, it's working fine, and you know how it behaves on your test data where you have the labels. But once the people are using it, what will they use it for? What is the client going to throw at your model? There is a very nice paper from Barbara Plank. I can highly recommend it. What to do about non-standard, non-canonical language in NLP. It discusses how performance varies compares to domains. And actually, she suggests to drop the notion of domain and to substitute it with the notion of variety space, because it's not just domain, say news or tweets, but it's also other factors. So you have social factors, you have genre, you have topic, and all these things will might make your the performance of your model bad. So how to control for this? You would like to have some way for controlling the quality of your model when it's running. You can use probabilities. I'll show one method for solving this problem. The method I will present comes from this paper from the Naver Labs called To Annotate or Not, Predicting Performance Drop Under Domain Shift. The idea is very simple. So you have some measure of measuring how much the test data will be different from your training data, and then you are going to build a regressor to predict the accuracy from this shift. This paper proposes 3 different methods for doing this, and I will today I will talk about one. I found that this method works very well. It's super simple. Don't need any changes to the model that you already have, and works very well. First, they this is how it works. Basically, you want to observe the performance of your model on the test split of your training data, so on your domains, and observe the performance of the same model on some other domain, and where you still have the label. So you have your training data, and then you have some 3 or 4 or 5 data set that are belong to different domains, but this is labeled data. And the idea is to take the difference in probability, the average assigned probability between your in-domain training data and the other domain. And the larger this difference is, the worse will be the performance of the model. How many different data sets for different domains you need to build this kind of regressor? These people show that already with something like 4 data set, you can get something meaningful. By the way, the method I'm talking about is this one called conf, because you're just observing the confidence of the model. This is a similar method. It has been shown that the probabilities of many recent neural networks are not so well calibrated, and that's why they show that the performance when you calibrate these probabilities. But actually, this week or last week, I saw one paper exactly about this problem, showing that the probability of BERT-based models are quite well calibrated. And for our case, I found that you don't really need to do any calibration. So already the raw probabilities that you get are fine. So this is nice because you can do something with the model that you already have, so don't need to do any changes there. What you see here is graph showing the correlation between the average probability indeed assigned by the model and the accuracy. And you can see that it's a nice, strong linear correlation. These are several datasets from the Amazon multi-domain dataset labeled by sentiment. And so you can see that you can use this average probability assigned by the model to the label to the instances to predict its accuracy. So if you're using some non-neural methods, non-neural models, something like engrams, then another solution for this same problem is to go for a data-oriented approach. So what you can do is to have a representation of your training data and say compute see what the distribution of words in your training data is, and then at test time you have some test data coming, and you can compute again the distribution of words of your test data, and then use something like KL or Jensen-Shannon to compare these two distributions and say if the distribution of the test data is very different from the training data, then I might have some problems there. But if you have some neural models, then better way to do this is by observing the performance of the model. And the reason for this is that these neural models would generalize anyway starting from the data. So it doesn't make much sense to look at just at the words. Any questions about performance prediction? No.
Well, I was thinking, Evgen is here, regarding the transfer learning, if it can be really like combined with what you just mentioned, but haven't come up with the right question yet. But is there anything that transfer learning in combination could boost some performance of confidence model, or you think it's not worth paying attention to this idea?
You mean after you've estimated the performance of your model, what can you do, right? I do understand the question correctly?
Yeah.
So say I trained the model on this data, then I have this other test data, and my performance prediction module is saying that the performance is not great. Then yeah, one option that you have there is say, maybe I can fine tune my model on this unlabeled data and then run it again. Yeah, of course, that's a solution. Yeah. Once you know that your model might not behave well on this test data, then you can take action. But if you don't have anything in place, then it's bad, right? Or you could even say, the alternative to this is that you have some people working full time and you have your test data. What they do, they take, say, 100 instances from this data, they label it by hand, and then they say, yeah, the model is working fine. So that's expensive, of course. So, yeah.
Thank you.
Too long, didn't pay attention. Train BERT, distill to a character-based CNN. Do the same thing, just to avoid the pipeline jungle, and take note of the probabilities on your test split in domain, because you can use it then at inference time. I'm done.
Good. Thank you, guys. Questions?
36 minutes, yes. Any questions?
If no one has questions yet, probably people are coming up. Regarding the company you are working for, you said you have an API as a product?
Yeah, you can request a key if you're interested in this sort of things. I forgot. So developer, yes. You can put some text here and see how it works. And then if you go here, request API key, yeah, you can get it from us.
Okay. I hope the participants of today's meetup will get some extra benefits.
Of course. Just ping me if you're interested.
But my question would be regarding as we are talking regarding quantization and running production model, which is smaller but performs similarly. Have you tried to use that on mobile devices? Probably, do you have mobile devices set up? If you did, then what kind of experience you had?
No, I haven't. I've seen some work, and it seems it's super fast, but I haven't tried myself. Yeah, of course. These numbers that I showed you. So these kind of numbers, these are super nice for something like an API, but if you are on mobile, I guess these are still bad. So you might want something in the range of 1 megabyte or something like that. TensorFlow is doing a lot of work in this direction, so that you can even export your model to something that you can load from JavaScript, so that it runs in your browser. But then you still might need something like this as an intermediate step, right? Say, if you want to maybe export to JavaScript some complicated model, it might not work because the model has to be built using only TensorFlow native layers, for instance. So if you have some custom layers, you might want to distill to something that is only using native layers and then export to JavaScript model. So you might still need something like this for doing mobile stuff.
Yeah, I see. Okay.
Any other question? Oh, we have the chat here. Checked it at all, sorry.
Hen asks, how do you tune the student model? How much data? Hyperparameters.
Data, as much data as you can. But that's not a problem, right? Because you need unlabeled data that you will label with your model. My experience, you don't really need to do much tuning. It works. Just let me find this paper for you. Deep CNN text classification. Yeah, something like this, without going so deep. Couple layers are enough for our task, at least, classification task. Yes. Juan, yes?
Feel free to drop the links to the chat as well.
Oh, yeah.
Quick access.
Juan raised hand. How can I mute or unmute Juan?
Hi.
Hi.
Hi. One question regarding how long are the texts that you are working, you are classifying, and did you try different strategy depending on how long the texts are using BERT or?
Again, how long the texts are?
Yeah, and did
Yeah.
you try different strategies depending on the length of the text?
Not really. So the issue there is that you have a theoretical limit. It's 512 tokens. You can go higher than that. If you have longer text, you have to chunk them and do some then post-processing. The issue is that the longer the sentence, the heavier the computation becomes. So unless you have some very large GPUs or a lot of them, there's not much you can do there. So it also depends on what kind of data you're working on. But ideally, you might want to do some sentence tokenization and work with sentences, because that's what it really is, right? A sentence embedder. So yeah.
There is a question from Hen. Can you take a look into the chat as well?
So the approach is to try to get the student model to the best performance without the teacher, and then use distillation with the same hyperparameters. So the student model can be anything you want. Could be also some big of words model with some logistic regression. And what it will learn, say that your teacher model is doing binary classification, so it will give you two labels, then your student will just be a regressor with two heads, predicting the probability for each output. So one will predict the probability for positive, and the other will predict the probability for negative. But with respect to the architecture of this student, it could be everything you want. But ideally, you want something that is powerful, but not too powerful that, again, will be so heavy, as heavy as the teacher, right? Does that answer your question? Yes, perfect.
So can I ask you a bit more about the way you organize infrastructure? Like, for instance, how do you manage models? Do you need to update them often? Is it like fully automated, or it's always a pain to change something?
No, it's not a pain. So there are now some nice products for serving your models once you have it trained. If you use TensorFlow, you might be interested in something like TF serving or serving. They provide you with a Docker image. You just put your model there, and it will create a first API for you. Something else which is very nice is Tensor. Just how can I get? Oops, a bit annoying. Sorry. How can I get this here to work? tensor RT inference server. Now it's called Triton inference server. It got some rebranding. Is that the same thing, but supports also other frameworks? Same thing again. We have your model, and you can see they have some strategy for managing a model repository if you have different versions. And this creates a first API, and then you still have to call this. You might want to build something on top of this, right? Because you might have some other logic. Yeah.
We don't see the NVIDIA screen, by the way.
You don't see this?
We see the same.
Yeah. Sorry.
Just the link somewhere in the chat.
Yeah, in the chat it's cool. Yeah.
Are you seeing this now, right?
Mm-hmm.
Yeah.
Okay, I didn't know about this one.
Yeah. I think PyTorch also started doing something like this. So there are several solutions for this problem. Yeah. Of course, you can also create your own, just for the model and build some API on top of it. But yeah, might not be ideal.
Okay, thank you.
Any other question?
Do you have the current setup, infrastructure setup? In the current infrastructure setup, how do you, for example, augment data over time? For example, you have a data set in state in the version 1, and then, for example, you get more data from a customer, and then what do? Do you have this as a separate data set, and then you test them independently? I mean, on these both data sets, or you combine somehow them together and then have a test for the same model that you used before?
If you have data from the customer, usually it's unlabeled data, right? So you can't. It's not so easy to do that. You might want to, if you are allowed to. Maybe it depends on the regulations that you agreed on, and maybe you might want to take a look at this data to see how the model is working there. Yeah, but ideally you might want your own data labeled and controlled by yourself. Yeah.
Sure. So I think if I simplify the question, did you face a problem when you have to maintain not only the models but the data sets, for example? So you tested the model on one data set, and then you got more data.
Oh yeah, this is a huge problem. Also because sometimes maybe you have some models trained, I don't know, 2-3 years ago from people that maybe left the company and still are important, and you have to compare them to the new model. I don't have much there to say, but just that it's a big problem. Something I like a lot, I'm starting to play with it, is this TensorFlow dataset tool that has a nice feature that allows you to version your dataset. That is very nice, so that you can easily compare the performance of your model against different versions of the dataset.
Can I jump in on that real quick? So we have this problem as well, and we found a very nice solution, which is called DVC.
Okay.
So it's basically, so it stands for data version control, and it works kind of alongside Git. So what you do is...
This thing?
Sorry?
This thing?
Yes, that thing, exactly.
Cool.
So it's very nice because it kind of separates the storage side of your data from the versioning side. So essentially, you store it stores your data for you in like S3 or Google Cloud Buckets or locally or whatever. And what it does is it creates a little kind of file like with a checksum to your data, and that file is the file that you version. So essentially, you version it however you normally version things, so probably in Git, and so you get kind of the full power of Git for versioning. I can recommend this. We set up our system around this, and it's worked very well for us.
Cool. Thanks a lot for sharing.
Thank you, Svetlana. Probably it's a topic for your presentation as well next time. All right, guys. Do we have more questions? So, doesn't seem like so. In that case, I propose that we finish for today. Of course, if everything goes smoothly, the recording will be available afterwards.
Let me pass something in the chat. So
Yeah.
here, you can find my presentation. It's on my website.
Mm-hmm. Yeah. I will share as well whenever I posted the announcement regarding the meetup itself. So it will be there and duplicated anyway. So thank you everybody for joining today. I hope that you'll join the next meetups like this. I personally enjoyed the presentation. I learned a lot of different interesting things. I hope you did as well. Angela, what's your impression about the meetup today?
Very nice. You have a very nice community here. Cool.
All right. Thanks, guys.
Thanks a lot for coming,
yeah.
people.
So have a good Saturday and Sunday. Take a rest and be healthy, right? Cheers.